Yeah. Okay, right. Can you hear me, guys?
Yes, yes.
Yes, sir.
Yes, right. Okay. But I told. Okay. So definitely, guys, inshallah, you will have the exam on August 6th. Though it is starting on August 6th or it's coming week, I don't know. Still we didn't get. But it's starting from
Only
August
10 days
6th.
there.
Obviously. So August 6th means we have only this week and the next week. The 6th is, I think so, that is a Friday, okay? I have checked. August 6th is should be Friday. Wait. Is it a Friday? Yes, of course. The August is a Friday. Obviously, you will have the part one paper or whatever. So this time I already told you all, so you can be remembered. You have 2 hours MCQ paper, 3 hour part two paper, right? Your paper two, paper one, right? This is MCQ. So that should be 2 hours, 3 hours altogether. You're going to do the 5 hours, right? So we have complete up to the unit 9. Definitely you will be questioned by each session, in MCQ as well as in your paper 2. Right? When you go for the structure, right, definitely you will have the question 1, you know the Lewis structure. The question 2, you definitely know that is the inorganic chemistry. The question 3 and 4, you know that what we are studying in the organic chemistry. So guys, why I have shared you the, yes, set up the short note papers, because please study. Definitely I'm not going to ask the conversion and those things we are not going to do now. After completion of these all syllabus, then only you can perform the conversion. The conversion is your part. So I'm not going to test the conversion here, because why? We didn't complete the syllabus yet. We have to complete up to unit 10. Unit 10 is a very small one. So I didn't do the unit 10 within this term, inshallah, definitely, because we will have to work with so many questions. At least the minimum 5 years past paper, conversion and the structure should be. So minimum 3 years, target is like that. So minimum 3 years after completion of this. So inshallah, if school reopen, that should be really good, right? So the working on that is really important. So please study. This time you can score the organic chemistry in very good manner. Very easiest one. All are separated now, and what is say extracted, you can see. Extracted and given. Study and come. This is what I used to say. So question number 3 could be either gas or enthalpy. Your physical question. So I said the rest part you have 5, 6, 7, 8, 9. Out of these 5 questions, you have to answer, right? So usually you will have one organic question, inorganic question, enthalpy question, gaseous question, right? And mixed up for the all questions should be there. You can select an only. So please study and come and be okay with this MCQ minimum 5 years paper up to unit 9. Practice 5 years paper only up to unit 9. At least practice and come. Then only you can do. Inshallah, I'm not going to do, right? So once I complete the unit 9, I want to do the MCQ minimum 5 years. After completion of that, I will do the structure part. This is what I want to do within this period. Okay, guys. So let's we do. So yes, give me a second. We have studied about the carboxylic acid, right? Can you define the shape of the carboxylic acid, guys? Yes.
CWH.
Yes, when you have, so when you said about that, the carboxylic acid, now the carboxylic acid having what the carbonyl group, CO, and like your alcohol, it has the OH group too, right? This is what the two functional group and what kind of the interaction that you can see in carboxylic acid. Yes? Yes, my dear students. What type of the interaction? Should I able to tell? Last time I have done until this, right? So you should know, right? The comparison, everything I have taught you, right? Usually they able to form dimeric structure. What is mean by the dimeric structure? Wait, structure. Okay. Can you see the presentation? Okay. Guys, can you all see the presentation?
Yeah, miss.
Okay, structure, the properties and sentences, their introduction, just for the recall, right? One week is not there, right? Okay, so when you speak about the carboxylic acid, we spoke, right, the COH group, right? Like your carbonyl, it has the CO group, and this is what the structure of the carboxylic acid. You can clearly see, yes, okay. You can clearly see here, you have the carbonyl group as well as the alcohol, OH group, hydroxide group. This is what we are talking about the carboxylic acid. Right. So next part, yes, physical properties. So we know the carboxylic acid having the COOH form. So therefore, we are calling that is as a polar functional group. Therefore, you know that is having what the CO bond is here, OH bond is there. So they are able to form what the dimeric structure. So which is able to form what the intermolecular hydrogen bond. That hydrogen bond, why this is having the CO bond and the OH group, therefore it is capable of forming the dimeric structure when the two molecule of the carboxylic acid is there, bonded together. So what is called by the dimeric structure? The structure I'll show you. So this is what the shape of the dimeric structure. Simply you can see here, right? Here the one hydrogen bond and another hydrogen bond. This is your one carboxylic acid. H, CWH. And this is your another carboxylic acid. Between these two carboxylic acid, can you see? Wait, I'll use another color. Yes. Can you see the bond? This is between your OH and this is between this H. So you can see the two one hydrogen bond. Compared to your alcohol, that is also able to form the hydrogen bond. But your carboxylic acid able to form the two hydrogen bond. That is what we are calling the dimeric structure, which is the most stable. Therefore, I said the boiling point comparatively, right? When you compare with same comparatively relative molecular mass with your aldehyde, ketone, alkane, alcohols, your carboxylic acid will show highest boiling point. Why? It has the strongest hydrogen bond which is able to show the dimeric structure. Are you all clear? Are you all clear, guys? This is what we studied, right? The intermolecular force, hydrogen, okay, this table, I spoke about that. And when the lower molecular, what I said, when you have the lower carbon atom, that carboxylic acid only will dissolve in water. When the carbon number of the carbon increases, the non-polar part of the alkyl group will be increased. Therefore, the solubility with water also decrease. This is also we discussed in this.
Miss, when carbon atom okay.
Increase. The low only C12, you can see only C12, C4 only dissolve in water, which is able to form the hydrogen bond. As the number of carbon atom increases, the solubility decreases. This is why the non-polar group part is increasing. The interaction, the bond making probability will be decreased, therefore solubility is decreased, right? This is what we studied. So usually I said all carboxylic acid will be dissolved in your organic solvents, right? This is what we studied last Friday. Obviously, Friday or Thursday, I don't remember. Right, it's a Thursday, right? We have completed up to that. Today we are going to speak about the comparison of the reactivity pattern of COOH group with having a CO group in aldehydes and ketone and OH group in alcohol and ketone. Why they are comparing this COOH with aldehyde ketone and alcohol and ketone? What was the reason? So I said, okay, when you take carboxylic acid, COOH, and this is we'll say just as it's a kind of the alkyl group. I'm talking about the carboxylic group, only this one. As like your aldehyde and ketone, right? This carboxylic acid able to show the carbonyl carbon. So we are going to speak about having this CO bond. We are going to compare with aldehyde and ketone. And also it has the OH group. Now I am going to speak about what? Yes, phenol and alcohol. I'm just going to speak about the comparison. How this cleavages happen, how the reactions happen. This is why you have to understand why we are doing this comparison, because of this structure, because of this functional group that it is having. So what kind of the reaction that is able to undergo. Did you all understand? So it able to undergo two type of the reaction. One is what? I'll use another color and yes. One should be what? The cleavage of the CO bond. And next one, the cleavage of the OH bond. Like your aldehyde ketone, another one is phenol and alcohol. Are you all clear? Are you all clear? Yes? Yes, guys. Can you all hear me? Hello? Hello, guys? Shaheen, Zain, are you all there?
Yeah, yes, miss.
Are you all clear, guys? Shall I move on? Okay? Thank you. So, according to this, right. So, I said having the OH group like your carboxylic acid undergoes a reaction cleavage of the CO bond and the OH group. Right? The first reaction involving of the cleavage of the OH bond. So, the first we are going to speak about the cleavage of the OH bond. The first, sure. Right. Sorry. Okay. The first thing we said, the carboxylic acid more acid than others, right? So as we said, the carboxylic acid is it's a good acid, right? Therefore, they are able to react with alkali metal and alkaline solution. So can you say this carboxylic acid group able to react with alkali metal? What are the alkali metal and alkaline solution? Can you define or example whatever?
Alkali metals are group 1.
Hmm.
Alkaline solution is basic solution.
Yes, we are talking about the basic solution and the basic metal. So when you speak about the alkali metal, you can speak about the obviously the sodium, potassium like that. And the alkaline solution, usually we are speaking about the
Sodium
basic
hydroxide and
like this.
potassium.
So and also the basis when I speak about that, not only this alkaline solution, not the sodium hydroxide, the carbon, sorry, potassium hydroxide, they able to react with sodium carbonate and sodium bicarbonate. This is the difference between us. We have the table. We will talk about that later. But you should able to understand this carboxylic acid able to react with alkali metal and also the alkaline solution. When you speak about the alkaline solution, there should be sodium hydroxide, potassium hydroxide, as well as the sodium carbonate and the sodium bicarbonate. Let's we move on to the reaction one by one. Are you all clear? Are you all clear? If you say yes, then only I can move. Processing.
Yeah.
Okay.
The sodium bicarbonate is alkaline solution.
Yes. It's a V-based solution. Not strong. It's a kind of V-based solution. Sodium hydroxide, potassium hydroxide, sodium carbonate also kind of the strong. Sodium potassium is a very strong base solution. Bicarbonate is a weak base solution. We will study this is at your equilibrium unit 12. Very large unit. Yes, clear.
Yeah.
Thank you. Right, clear and use the color. Right. The first thing is when you say about the carboxylic acid, I say we'll write RCOH reacting with your metal sodium. Obviously, you will get the salt. How should be the salt? Any guesses? Yes? Any idea? Minus Na plus. With evaluation of the hydrogen gas. So whenever you write the reaction, guys, you should be able to balance the reaction and write. Right? I'm not writing here balance reaction. I'm just teaching you all how to write the reaction first. Whenever the carboxylic acid react with your sodium metal, it will end up with the carboxylate ion, the sodium ion, right, with the evaluation of the hydrogen gas. Are you all clear? Are you all clear?
Yes.
So next, you all should be able to tell RCOH plus reacting with sodium hydroxide. Anyone?
RCOO
Answer.
minus Na plus water.
This is what? With yes, water. Is it easy, right? Hmm?
Very easy. But in the
Very
paper
easy.
coming different.
If you study, you can apply, right? Okay, fine, we'll do, don't worry. And next, your RCOH, your carboxylic acid reacting with sodium carbonate. Any guesses what should be the answer? Definitely the salt is there, right? I told.
Bicarbonate is there.
There should be bicarbonate. Or any other answer? Any other answer? Okay, bicarbonate.
Bicarbonate.
Then? Then? But only bicarbonate. Only bicarbonate. Zain, what about you? Zain is there, right? Whenever see the sodium carbonate, what kind of the gas can be evolved?
hydrogen and carbon dioxide.
Yes. Whenever see your sodium carbonate, the carbon dioxide is evolved. And the rest part is the water, not the bicarbonate. Clear? Clear? So can you say now your carboxylic acid react with sodium bicarbonate? What should be the answer? Now it should be easy. Again, yes.
By
Again, salt. You are having the carbonate ion. So evaluation of the carbon dioxide. Keep water. That's all. Are you all clear?
all same numbers.
Yes. Only the balancing part will be different. Earlier, if you balance the reaction, okay, I will show that is later, but now I will balance the reaction. You can see here you have the 2, therefore you are putting 2 here. If it is this is 2, you have the 2 carboxylic acid. But now check here, 1R, right? Okay, here sodium is 1, sodium is 1. This is you will get what? Half of the molar ratio. If it is, this is when you use the sodium carbonate, you will end up with the 2 mole of the carboxylate ion. But when you use the sodium bicarbonate, you will end up with 1 mole of the carboxylate ion. Are you clear now? Yes, guys. Is it clear now?
Yes, yes.
Okay. Yes, Zain. Crystal clear. Is he there? Okay. He is missing. So
No, miss, it's raining here, so I think connection is.
yeah, here also raining. I really wanted to take the class today morning. I didn't allow my child to go to this school also. School means Zoom class. Heavy rain, right? Okay, I said, okay, this is what is reaction happens. These reaction, all reaction, just now we go one by one. Right, the first reaction, when it's react with the sodium, right, the ratio you have to balance, right, you will end up with what? The evaluation of the gas. When you use the alkaline solution, you will end up with the water. When you use the sodium carbonate, you will end up with the CO2, water. The bicarbonate will give again the same, but the molar ratio is different. This is what you have to know. This all. Are you all clear? Okay. Now let's move on to the comparison reaction of alcohols, phenol and carboxylic acid with sodium hydroxide, sodium carbonate and the sodium bicarbonate. Why I'm talking about that? Here we are talking about the cleavage of the OH group, right? So when you speak about the cleavage of the OH group, it's simply similar for what? Like your alcohol and phenol. So having the alcohol phenol, we are going to compare the reaction mechanism with sodium hydroxide, sodium carbonate plus sodium bicarbonate. Sorry. These are the things that we are going to speak now. So you should be able to know how to differentiate it. What is the difference between the carboxylic acid, phenol and the alcohol? What kind of the reaction products that you can obtain? This is what we are going to study. Are you all clear? Shall I move on to the next slide? Okay. The reaction of the alcohols, phenols and the carboxylic acid with sodium, sodium hydroxide, sodium carbonate and the sodium bicarbonate, right? You have 10 minutes more guys. After finishing, you can rejoin the class, right? Okay, so this is the table. Let's talk about the thing one
So
by
what is
one.
it by heart?
Sorry? By heart.
What should we by heart?
It's a kind of the
Table.
extraction. You have to by heart, definitely. If you know the reaction, you no need to by heart. But when you do like this tabulation, it should be really little bit understandable. So look at here. What is happening? The reaction which we are going to speak about the metal sodium, sodium hydroxide, carbonate or bicarbonate. Why? The same product. Okay. What should be the product? When this is what is the first one is alcohol. Okay, I'll write here. Alcohol. What is this? Phenol. What is this? Carboxylic acid. Okay, these three going to perform the reaction with these different reagents. The first one, alcohol reacts with Na. And you know guys, we have studied the alcohol, only one reaction, the sodium reacting with that and providing what the alkoxide ion. We studied. And there is no more reaction with sodium hydroxide and the sodium bicarbonate and the sodium carbonate. You asked, what is the reason that I have to by heart it? Definitely, you separately you studied these things, alcohol, phenol, the reaction and everything. Different. Separately we studied, but we don't know how to combine and see this one. For that visualizing pattern, right? It's really become very easy when you make such kind of the tabulation. Go for the phenol. The phenol comparatively strong acid than your alcohol. So we know because of the phenoxide ion, the resonance stabilization of the phenoxide ion. Simply as like your alcohol, the phenol able to produce the H2 gas with forming the phenoxide ion. Okay, sodium phenoxide ion. And also you can see this phenol dissolving, you have to know, the sodium hydroxide and forming a solution. It's an evaluation of the hydrogen, it's forming a solution of the phenoxide ion. But phenol, it's never show the reaction with sodium carbonate and the sodium bicarbonate. Right? Okay? And just now we studied the carboxylic acid. Yes, the carboxylic acid, when it reacts with the sodium, it able to produce what? The evaluation of the hydrogen gas with what? The sodium carboxylate ion, right? And when it reacts with your sodium hydroxide, it dissolves in a water. Sorry, dissolves in the sodium hydroxide, forming a solution called that, carboxylate ion. And finally, when you use the aqueous sodium carbonate, sodium bicarbonate, they dissolve in the sodium carbonate and the bicarbonate, forming a sodium carbonate, carboxylate ion, and liberating CO2 gas. So comparatively, you can say the alcohol, right, only react with, yes, sodium. Phenol react with sodium and the sodium hydroxide. But the carboxylic acid reacts with sodium, sodium hydroxide, sodium carbonate and the sodium bicarbonate. Are you all clear? Are you all clear? Okay, are you all clear this table? Is it clear? This tabulation? Do we need time to process these things?
No.
Right? Okay,
No.
that means you're asking not, you're telling not clear, or it's no need the time to process the answer.
No, no. Clear, clear.
Clear.
Don't need.
Thank you very much, right? So simply you can say, okay, I need a blank one. That's why I want to move on, right? So simply you can say, okay, okay. So when you take the alcohol, we'll make a chart. Make a chart, right? Alcohol, the sodium, sodium hydroxide, sodium bicarbonate, sodium carbonate, right? Uh, okay, one is for alcohol, one is for phenol, one is for carboxylic acid. Now you can write here as alcohol, phenol, ask mama, phenol, carboxylic acid. Right. So it's a kind of the extraction. So alcohol reacts with only the sodium, right? Liberating with H2 gas. They never react with the sodium hydroxide, sodium bicarbonate, sodium carbonate. Go for the phenol, right? It's react with the sodium metal, yes, and liberating what? H2 gas. When it's react with the sodium hydroxide, yes, it able to form the solution, the phenoxide ion C6H5O minus Na plus. Yes, it's reacting, but it's never reacting with these two. And again, here that is able to, here you able to say what is the alkoxide ion RO Na plus. Here phenoxide C6H5O minus Na plus. And when you go for the carboxylic acid, RCO minus Na plus. And here it able to produce the solution that is also RCO minus. This is with H2 gas evaluation. Here also RCO minus Na plus solution. And again with carbonate ion that is able to form the reaction, right? And this is also able to form the carboxylate ion aqueous solution with the evaluation of the carbon dioxide. So you are able to extract, you are able to construct such kind of the thing. Then you will be clear. How can I differentiate? What is the reason that alcohol, phenol, carboxylic acid only can react with the carboxylate? This bicarbonate and the sodium carbonate. That is the reason the acidity strength of the carboxylic acid comparatively is higher than your phenol and alcohol. This is what is the reason they able to react with the basic alkali metal and the alkaline solution. Are you all clear? Shall I erase it? Are you all clear? Yes, guys.
You okay, miss?
So what is the reason of having? Why this such kind of the difference? Yes, the acidity strength. For carboxylic acid higher than the phenol than alcohol. We know all the time the phenol higher than the alcohol. Why? The phenoxide ion is resonance stability is more stable than your alkoxide ion. Likewise, your carboxylate ion more stable than the phenoxide ion. So next, Okay, it will finish now. So